Have you ever wondered why pre-processing should be done on the CPU instead of the GPU? It might seem counterintuitive, but today we're going to break down the reasons behind this recommendation. I totally get it. It can be confusing when you're trying to optimize your machine learning workflow. Many people share your concerns about why we should prioritize CPU for pre-processing tasks. Let's dive into the specific question at hand. One user asked, why does the performance guide recommend pre-processing on the CPU? They highlighted two main points: avoiding back and forth data transfer between CPU and GPU, and allowing the GPU to focus solely on training. So why does pre-processing send results back to the CPU? Even if all nodes are on the GPU, certain pre-processing operations can still require data to be sent back and forth. This can create unnecessary delays. Now, let's address the second concern. While pre-processing tasks like random cropping and flipping may seem minor compared to heavy training computations, they can still impact overall throughput significantly. Stay with me, because by the end of this video, you'll have a clear understanding of why CPU pre-processing can actually boost your performance. First, let's discuss why pre-processing on the CPU is beneficial. When data is pre-processed on the GPU, it often needs to be sent back to the CPU for further operations. This back-and-forth transfer can slow down the overall process. Next, by performing pre-processing on the CPU, the GPU is freed up to focus solely on training tasks. This allows the GPU to utilize its resources more efficiently, enhancing training performance. Now, let's address the computational needs of pre-processing versus training. While pre-processing tasks like random cropping and flipping may seem minor, they can still add up. The CPU can handle these tasks effectively without interrupting the GPU's workload. Finally, the performance guide indicates that using the CPU for pre-processing can yield a significant increase in throughput, sometimes up to 6 times. This is because the CPU can manage these tasks without the overhead of transferring data back and forth. Fun fact, the CPU is like the brain of your computer, while the GPU is like the muscles. You wouldn't want to tire out your muscles with unnecessary tasks, right? Now let's look at the answers provided by other users. In conclusion, pre-processing on the CPU can yield a significant increase in throughput, sometimes up to 6 times more, allowing your GPU to shine during training. And there you have it. Understanding the balance between CPU and GPU tasks can greatly enhance your machine learning performance. If you found this video helpful, don't forget to subscribe for more insights. This user explains that pre-processing on the CPU can prevent data from bouncing back and forth between the CPU and GPU. They note that certain operations like file reading and queuing must be done on the CPU, while others can be performed on either. This means that if the code doesn't specify the CPU, it may end up switching between the two, which can slow things down. Regarding the performance increase, the user mentions that while pre-processing may seem less intensive than training, it can still take a significant amount of time, especially with smaller networks like those used for MNIST. They suggest that the reported 6-fold increase in throughput is likely due to the relatively larger impact of pre-processing in these cases.